Hi, students. Hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in short-range wireless communication, where we're going to see elements of wireless communication system in this particular video. This particular question is very important question in this particular unit, elements of wireless communication system, where we're going to see about transmitter, receiver, what are the different technology involved, what are the different types of sources, what are the message formats, what are the different conditions for transmitter and receiver, what are the different types of antennas that can be used. All these things we're going to see in this particular video. Right, before starting this video, I would recommend you people to go and watch the previous video where I have just said about wireless communication, the introduction about wireless communication, the introduction about short range wireless communication, so that you can understand what is wireless communication, what are the important advantages and disadvantages, the applications, challenges, all those things. So it will be very easy for you to understand this particular video if you watch the previous video, right? So with this, I'll start this particular video, elements of wireless communication system, right? So in elements of wireless communication system, we know in any wireless transmission, I have said you have a transmitter and a receiver. So any particular message that is transmitted between a transmitter and a receiver with air acting as a transmission medium, then that is called as wireless communication system. And if you take any wireless communication system, these are the very important elements of it. And that is data source, RF generating section, RF conduction and radiation, radio channel, receivers, power supply. I would like to explain in detail about everything in this particular slide, and then I'll just go through the slides. The theory part will just go through one by one, but the overall working I will explain you in this particular slide itself. Right. So elements of wireless communication system. First thing is data source. Right. For a transmitter, you have a data source, modulator, RF amplifier, RF source, and an antenna. Right. Whereas a receiver, you'll have all the elements of transmitter even in receiver, but in different version of it. You can see LNA, which is nothing but the RF amplifier, and you'll have a RF down converter, which down converts the frequency, and you'll have a detector, which performs the opposite operation of modulator, like that, right? So when it comes to RF generating section, RF generating section is nothing but it comprises of the oscillator, the RF source, the modulator, and as well as the RF amplifier. So these three parts is called as RF generating section. And what is RF conduction and radiation? That speaks only about the antenna. What are the importance of antenna? What are the antennas we're going to use? What are the characteristics of antenna? Right? That is about RF conduction and radiation. And what is radio channel? We're going to speak about the channel, that is the air. Air is going to act as a channel here. So what are the changes that can take place with the transmitted signal while traveling in the channel? That is what you want to explain in radio channel. And when it comes to receiver, you have to explain once again about LNA, down converter, detector, all those things. And obviously, the very important concept is power supply, right? We will see one by one. When it comes to data source, first I'll start with transmitter. When it comes to data source, we know that the data source, the original information can be an analog message or a digital message. An analog message is nothing but represented like a sine wave, and a digital message is zeros and ones. That is, it can be represented by a square wave. So the data source can be analog or digital, depending upon the devices which gives that particular information or it generates that particular message, right? So these devices can be a very simple devices like uh, an intruder detector, a panic controlling system, or a panic indicator, right? So these systems are just nothing but it will send an indication uh, about the change of state. Say, for example, if there is an intruder, if you have an intruder detection system, if there is any intruder, it will detect the intruder and it will send the message, right? Until or unless if there is no intruder there, it will remain in the same state and it will change its state only when there is an intruder. Similarly, until a panic button is pressed, the panic system will be in the same state. Once you press the panic button, it will send the signal, correct? Right? So it can be used as an on-off signaling, very simple device which can use an on-off signaling, right? Just a change of state. That's the change of state has to be transmitted through RF signal. And not only that, it can all be the source can also be an audio system, right? Where we will send the audio signal or video signal, or we can use the computers where it will transmit digital signals. So data source can be analog or digital, right? And that particular message which is coming out, that has to be transferred very securely. So there should be some particular technique to safeguard that particular message. So there should be some particular technique to detect the errors, to correct the errors, all those things. We will see all those information in detail, right? And then comes modulator. What is modulator? Now the information which is need to be transmitted is converted to RF signal, right? That RF signal has to be transmitted to a very longer distance, right? For that, we need RF generating section. What is RF generating section here? It's about modulator, RF amplifier, and RF source. So what is RF source? I have already explained what is modulator in previous video where I have spoke about basics of communication. So modulator is the one which performs modulation. It's nothing but superimposing the message signal over the carrier signal and transmitting for a longer distance, right? So the RF source here, it will act as an oscillator which generates the carrier signal, and that carrier signal will be combined with the message signal so that it can be transmitted to a very longer distance after amplifying it. Right? This is about RF section, and once it is ready to transmit, then we go for RF conduction and radiation, where the antenna plays a very vital role. The antenna transmit that RF waves, right? It will transmit that RF waves, it radiates that RF signal, and at the receiving side, right, that particular signal will be received by the antenna, where the air is acting as a communication medium here. The transmitted signal will be transmitted through the radio channel, the air, and it is received by the receiver antenna. Once it received by the receiver, now the receiver has to do a lot of processing techniques to understand what is the original message, right? So originally we would have transmitted zeros and ones, but after converting to RF waves and after doing modulation, now the receiver has to do a lot of techniques, lot of things that is done at the transmitting side in a reverse order so that it will get the original message signal, right? So once it receives the signal through the antenna, once again what it will do is uh, it has to amplify the correct signal, right? You'll not only get the desired signal here, you'll also get noise, desired signal plus noise. So now the receiver have the responsibility to detect the correct signal, right? So that is very, very important, right? So the ability to select the correct signal, the right signal, that is called the selectivity of the receiver, right? Even though you have number of signals very closer to that particular frequency, the receiver has to select the correct signal. That is called the selectivity of the receiver, right? Which is a very important parameter. And another important parameter is sensitivity. Selectivity and sensitivity is very important for a receiver. Selectivity is selecting the correct signal among the available signal, even though if it is very close to the that frequency range, the receiver has to select the correct signal, right? That is the selectivity. We can also put it in other words, the ability of the receiver to reject the unwanted signals, right? And selecting the desired signal, that is called a selectivity. What is sensitivity? Sensitivity is after selecting that particular signal, it has to amplify the desired signal, right? Even though if the desired signal is very weak, it has to amplify that particular signal. That is called as sensitivity, right? So selectivity and sensitivity is very important for receiver, right? And once the signal is selected and amplified, it has to be sent to the down converter. So what is down converter? Now, down converter is we have to reduce the frequency range. That is, it has to reduce to a frequency range where we have to process that particular signal. Signal has to be processed and it has to detect, right? So it has to convert you would have received in a higher frequency range. So it has to be converted to an intermediate frequency, IF frequency. It has to be converted to intermediate frequency so that the signals can be processed and you can able to detect the original signal. So that process can be done by RF down converter, right? So it will convert the received signal to an intermediate frequency, and then that intermediate frequency signal is sent to the detector, where detector will perform the inverse operation of the modulator. Whereas in transmitting side, what it will do, it will combine the message signal and the carrier signal. Whereas here, it removes the carrier signal and it will have only the original signal. And from that particular original message signal, we can able to detect whether it is zeros or one which is transmitted. So this is the complete working of elements of wireless communication. But we have to explain about power supply. Power supply is very, very important, especially for wireless communication system. Power supply plays a very vital role. That's because any wireless device, like it is a mobile device, so all these devices are can able to move. It has mobility, but if it is mobile, if it is having this particular feature, the mobility, then it has to be a battery powered device. So when it is battery powered device, definitely power plays a very important role, right? So any gadgets right now you have, if it is battery powered, then the battery has to be recharged every now and then, and it has to be replaced whenever the battery is over, right? So the lifetime of the battery is over, then it has to be replaced. So you have this particular challenge. So any particular wireless devices, right? The main important consideration, many important requirement is low power consumption. Whether it's going to transmit or it's going to act as a receiver, it has to consume only low power. That is very, very important requirement of any wireless device. So for that, we have a lot of techniques to use this power very efficiently, right? And I would like to give you a very good example where in your laptops, right? Whenever you use your laptop, and if the laptop is inactive, you would have seen that laptop goes to the sleep mode, and whenever you come back again and you press any particular key, it will come to the normal mode, right? That is done only for power consumption, to reduce the power consumption. So similarly, any particular wireless devices, right? This power cycle, right? This duty cycle has to be there to reduce the power consumption. And when it comes to transmitter side, it is very simple. That's because we can able to reduce the power consumption in transmitter side very easily. Because in transmitter is going to just transmit the message, so it knows when it is going to transmit a message. So the transmitter can just transmit the message, and as soon as it transmit the message, it can go to the sleep state. It can go to the low power state, right? And once again, whenever it want to transmit, it can come again to the normal state and it can able to transmit. So it will be turned on, or it can be in full power state only whenever it is transmitting. And apart from it, it will go to the low power state, uh, right? Or to the sleep mode, where you can able to reduce the power consumption. But whereas in receiver, you have this challenge where the receiver will not be able to know when it is going to receive the particular signal, right? So it has to be active all the time. So in that case, power consumption by the receiver has to be uh, very effective, right? There should be a proper duty cycle for receiver also, so that we can able to regulate this power consumption, right? So what can be done is we can able to, similar to the transmitter, we can able to make the receiver like it can go to the sleep state until it detects an initial signal reception. Once it detects an initial reception, it can go to the active mode. So all these things you have to explain in power supply, right? So whatever information which I've said right now, we will see in depth about it. So first is data source. As I said, data source, it can be an analog or digital, right? And like I said, what is analog signal, what is digital signal? The very important thing is, if any particular message, it has to have the address bit, data, and as well as parity. What is address bit? Address bit, it will have the information about uh, the the transmitter and the receiver, who's going to transmit and who's going to receive. You'll have some identity, right? Identity bits. So that is called as address bits. Data is nothing but the original data that has to be transmitted between the transmitter and the receiver. And parity, parity is used to check the error detection, right? Whenever there is any problem with the received message, received signal or received message, then if there is an error, it has to be retransmitted, right? So for that, parity can be used. I would like to give you one good example. Say, for example, there is a transmitter like a parity check. That is, say, for example, you're going to transmit 0110. The transmitter is sending this particular message, and here the parity is even odd parity, right? You will have only 3 ones here, so it is odd parity. Now the receiver, if the transmitter and receiver is synchronized, right? The receiver receives this message like with an error. Say, for example, like this, it is received. Right now, the receiver must know that it is ready to receive uh, odd parity signal. But here it has received an even parity signal. So when it checks the parity, it will be an even parity. So the receiver will understand that there is some sort of an error. So what it can do is it will discard this particular message and it will ask the transmitter to retransmit that particular message. This is just an example. Like this, we can have any number of techniques, any technique to detect the errors. So parity bit is one such bit which is used to detect the errors. And the source can be even a computer where it can able to send the continuous digital data, where in data we will have a sophisticated error detection and correction techniques, or it can be an audio device where we can able to transmit uh, wireless microphones, headsets, sends an analog data, right? Or it can be a simple on-off signal, as I said, intrusion detector, panic button, or any control, remote control element, right? So you have different types of sources, and depending upon the sources, the transmission also can take place like FM transmission, where in FM transmission we use pre-emphasis and de-emphasis, where it will increase the frequency locally at the transmitting side, and the receiving side that will be suppressed. It will be reduced the amplification of that particular frequency, and dynamic range can be improved by using compounder. What is compounder? Compounder is nothing but you will have compressor and expander. That is, compressor will be used on the transmitting side and expander will be used on the receiving side, right? And more importantly, there is other sources as well. There is RFID, right? RFID, we already know what is RFID, radio frequency identification system, where this RFID is completely different from the normal transmitter and receiver. Whereas in RFID, we will have a reader and you'll have a tag where the transmitter will not transmit the message here, where the tag, that is the device which is having that particular tag, will have the original data. So whenever the reader, that is the reader will sense a RF signal, the electromagnetic signal, whenever this radio frequency signal reaches this particular tag, it activates this particular tag, and once the tag is activated, the data in this particular tag will be superimposed in this particular RF wave, and it is sent back to this reader. And now the reader, what it will do is it receives that particular message, it will process it by the computer, and then detects the original message. Right? This is the normal communication of RFID. Right? Whatever I said, that is what I explained here. Right? So RFID can also be another important source. And apart from it, the first data source, radio frequency generating section. So RF source, modulator, and amplifier is acting as a radio frequency generating section, where oscillator will generate the carrier frequency and modulator will perform the modulation and it is transmitted to a very longer distance. And whereas RF conduction and radiation takes place through the antenna. Right now we have a lot of sophisticated antennas. Even in wireless devices we have small inbuilt antennas where omnidirectional antennas. Right now we have omnidirectional is nothing but it can able to transmit, radiate in the same way in all direction, right? That is omnidirectional antenna. So RF conduction and radiation, I have explained about only the antennas. And when it comes to radio channel, right, we are going to have air as a transmitting medium. So when we are going to transmit this particular message wirelessly, right, even if it is indoor or external, all the short range communication going to take place only indoor communication. And if it is wireless communication, we have a lot of challenges where the RF power will be relatively low, and definitely it will be affected by any particular surface, human body, or any particular devices which is in and around of it. And the reliable operating range is very difficult. And the other important drawbacks is it is unreliable. That is, the manufacturer of this particular devices, right? They lack a knowledge of special propagation characteristics of each and every particular wave and the device. And similarly, the advantage of this short range devices or short range wireless devices is we don't have wires. It replaces hard wiring, but we have a lot of limitations in order of propagation where the errors, security, authentication, all this has to be addressed, right? And when it comes to receiver performs the same operation of transmitter but in the reverse order, where you can see same like the transmitter, you will have antenna, transmission line, RF amplifiers, oscillators, whereas here we will have uh, low noise amplifier which will detect the uh, desired signal and it will amplify that. And I already explained what is down converting, what is demodulator, right? And as I said, in receiver, two important parameters is selectivity and sensitivity, where selectivity is the ability of a radio receiver to reject the signals, right? Reject all signals which is very close to the desired frequency. And we can also say in such a way that the ability to select the correct signal, that is called as selectivity. Sensitivity is the ability of the receiver to amplify the desired weak signal, right? And we can use any type of modulation techniques, amplitude modulation, frequency modulation, or digital modulation techniques, right? So this is what you want to explain in receiver. And after receiving this particular signal, after obtaining the desired signal and amplifying it, we can use any modulation techniques. That is, in the transmitting side, you would have used amplitude modulation, frequency modulation, depending upon the application. Whereas here, it has to perform demodulation. That is, it has to separate the message signal and the carrier signal, right? So after separating it, right, after down converting it, after separating the carrier signal, it has to be sent to the user. That is the original message signal. We can able to detect the original message signal. And I already said what is down converting. Before doing this director value, demodulator value, demodulation operation, the received signal has to be down converted to a intermediate frequency where we can able to process the signal, right? And the last important thing is power supply. Regarding power supply, I already said we have to speak about the battery size. It is very important that we need to change batteries or we have to recharge it. Low current consumption is very important, right? The transmitter, as I said, it can go to a standby mode whenever it is going to transmit data, and whenever it is not going to transmit data, and it can come to normal mode when it is transmitting data. Similarly, we can work on the receiver duty cycle where to operate in a reduced power standby mode, operation goes to normal when beginning of the signal is detected, right? Until it detects the beginning of the signal, it can remain in the low power state, and until it detects the beginning of the signal, it can go to the normal state, right? It can go back to the normal state. So by doing that, we can able to reduce some power consumed by the receiver, right? So today, what we have seen is we have seen the elements of wireless communication system. This is very important question where you can write very easily by looking at the block diagram, and all the points which I said is very important. Whenever you explain about data source, you have to explain about analog and digital and what are the different data sources that is possible, analog devices and digital devices, and then you have to speak about the RF generation section and receiver section and power supply section. You have to explain all the points which I've said, right? I believe this video will be very useful for you. All the very best, my dear students. Thank you.